Hi everyone. So I wanted to build a compact workstation grade PC that has enough performance for 4K 120Hz gaming, the occasional video editing session, and any deep learning experiments that I can come up with. Initially, the build was planned around the SSUPD Mushroom S case, and at its heart would have been a PNY RTX 4090 card. The card doesn't look that nice, but it's compact enough to fit inside the ITX case. But then I decided to open Facebook Marketplace to see if there were any good deals available nearby. And to my pleasant surprise, I found a slightly used Gigabyte RTX 4090 card for about $1,500. Now that is $250 cheaper than buying a brand new 4090 from Amazon or Newegg. Now the Gigabyte 4090 is a pretty good GPU with good power delivery and well-cooled memory, but it's a bit too tall and long to fit cleanly inside the Mushroom case. That and the $170 that I would save by going for a Micro-ATX build instead also helped in finalizing the ASUS AP201 as the case for this build. So with the parts finalized, I ordered everything brand new from Amazon and from Newegg.com. Once the parts arrived, I started with the pre-build test. This involves assembling the core components of the build outside the case, so if things do go wrong, it's considerably easier to troubleshoot issues. So I took out the motherboard, installed the shiny new R9 7900X CPU, installed my 2 sticks of RAM, the 2 NVMe drives, and then the Gigabyte 4090 card. Once everything was connected and plugged into power, I booted up the PC by shorting the 2 pins for the power switch with the LTT screwdriver. And the PC did not post. I thought that's AM5 being AM5 and left the system for 15 minutes straight. But the status LEDs on the motherboard kept on blinking between CPU and RAM. At this point, I powered off the system. Then I disconnected everything from the motherboard except for CPU and RAM, but that didn't work either. I also tried different BIOS versions but to no avail. At this point I knew that at least one of the CPU, RAM or the motherboard were faulty. During my troubleshooting session, I found out that the new Ryzen 7000 systems can occasionally face issues with memory instabilities, long boot times, and even face issues posting reliably after certain BIOS updates. So I had two choices. I can either get a replacement motherboard that would take a week to arrive. At that point I could retest and find that some other component was broken. Or I could order the Intel equivalent of my current parts, which had 1-day shipping, and test out my components with those parts. So at 12:15 AM on Sunday, after exhausting all of my troubleshooting options, I decided to give Intel a chance. The new CPU and motherboard arrived at my doorstep on Monday evening. I then carefully put the CPU, motherboard and RAM together for the initial boot. And what do you know, the PC posted perfectly fine. I then installed my SSDs and the GPU, and the system booted into BIOS just fine, with the display signal now coming from the 4090 card. At this point, I decided to install Windows 11 Home Edition and set up the latest drivers from Intel and Nvidia. I verified that the built-in Wi-Fi and Bluetooth was working, the 4090 was performing as expected, and that the XMP profile was applied properly and was stable. For the PC case, I got the ASUS AP201. It's a compact mini tower case without going too small, which allows you to use standard ATX components in the build. It also has sensible front I/O and looks nice in my opinion. For the final build, I started with removing all the side panels and the front PSU shroud. Regarding the power supply mounting, the AP201 by default comes with its front PSU mount in its lowest position. In this position, the max GPU length is limited to around 335mm. To fit longer GPUs inside the case, you can move the PSU bracket to the topmost slot. With the bracket in this position, you can fit PSUs up to 150mm in length for maximizing GPU clearance. The Corsair RM1000e that I'm using here is 140mm in length. I used the screws that came with the PSU to connect the unit to the bracket. Then the bracket was installed inside the case. Once the PSU was installed, I laid the case horizontally and made sure all cables were out of the way. I then installed the motherboard assembly onto the motherboard tray and attached it to the case with the appropriate screws mentioned in the case manual. And this is what the build looks like so far. I then started plugging in all the front panel headers. I had to double check the connector locations in the motherboard manual. First was the front panel audio connector, then the USB Type-C connector, followed by the USB 3.0 Type A ports, and finally the power switch. Also, I made sure to use the central cable management channel to route the power cables and the main connectors. Once that was done, I removed the included case fan that was mounted as a rear exhaust. After that, I installed two of the 3 RGB fans at the bottom for intake. The included case fan was mounted to the top of the case as an exhaust, and the remaining RGB fan was mounted as a rear intake fan to throw cool air directly at the CPU cooler. This fan configuration maintains positive air pressure inside the case, which is important since the AP201 only comes with a bottom mounted dust filter. Rest of the mesh panels in this case do not have any dust filtration. Once the fans were screwed in, I daisy chained the RGB and PWM connectors and plugged them into appropriate headers on the motherboard. This did result in a small mess of fan cables behind the motherboard tray. After that, I routed the 12VH power connector to the front of the motherboard tray and laid the case horizontally. It was now time to install the big boy GPU into the case. I unscrewed the PCIe slot covers from the case, then slotted the GPU into the primary PCIe slot of the motherboard. Once the GPU was properly seated, I screwed in the GPU to the case. I then carefully connected the 12VH power cable to the GPU's power connector, making sure that the connector was fully seated. Now it was time to boot the assembled PC. I plugged in the power cable, pressed the power button and saw the RGB lights glow up nicely. I went into the BIOS and set up an initial fan curve. The cheap RGB fans that I bought were actually quite noisy at full speed, so I later set them up to a maximum of 50% fan speed. After that, I installed the front PSU shroud. I also installed a magnetic GPU support stand at the bottom of the case to support the absolute unit of a GPU. Once the RGB profile was set up in Armoury Crate, I installed the tempered glass side panel and did the final peel off, accompanied with some nice music. Once the fan curves were set properly, the PC was remarkably quiet during gaming loads and only slightly audible during stress tests. The one elephant in the room for this build is the use of a B760 motherboard with a K-series Intel CPU. I got this ASUS B760M tough motherboard since it's well built, has integrated Wi-Fi and Bluetooth, and was available with one-day shipping. By not going with a Z790 board, I am not able to adjust power limits or undervolt the CPU for better clock speeds. The result is that instead of getting 30,000 points on Cinebench R23, I'm getting around 28,000 points. In a 10-minute Cinebench run, the AK620 cooler can barely keep up with the CPU, and the average pico temperatures end up around 97 degrees Celsius with clocks around 5.1 GHz. And as far as the GPU is concerned, it's running at peak performance with cool temperatures. 30 minutes of firm arc results in temperatures around 68 degrees Celsius. In 3D Mark Time Spy, the PC hits 32,938 points, with the CPU hitting 20,332 points and the GPU hitting 36,985 points. So overall, the GPU is performing well, while the CPU is slightly slower for multi-core workloads and delivers close to peak performance for lightly threaded workloads. The PC also boots quickly, has 6TB of super fast NVMe storage, and looks great while sitting on my desk. So overall, I'm quite happy with how the build turned out. I wish the AMD CPU and Gigabyte motherboard had worked out, but the Intel CPU and ASUS motherboard ended up being a good enough replacement. The total price of all parts along with the Windows 11 license came to be around $3,340 after taxes. So this is a really expensive PC build, but is super fast and should work well for pretty much everything that I can throw at the system. That's all for this time, and thank you for watching.